Okay, I think we should make a start. Obviously, we're going to do the introductions first. So if a couple of people will join a bit later, that's fine. I think they're still going to get most of the content. Welcome, everybody, and thank you for joining. My name is Felix. I work for Nesta on the Engine Room project. I'm not going to speak much during this. I'm just kind of here to welcome all of you. Just to repeat again, you're all muted. Please feel free to ask any questions that you might have in the chat or raise anything if you can't hear something or something. Necessary, you can obviously also unmute yourself. And just a reminder again, we are recording this and we'll upload it on our website. So any questions that you ask either in the chat or via voice will be included in that recording. And you can obviously then come to our website and have a look at the recording later or share that with other people. And if nobody has any issues, any questions, I would ask Katja to start us off giving a quick introduction of the project, and then we'll move into the actual data science.
Hello, everyone. So thank you for coming. So I can move my own slides, so Felix, maybe you can. So very quick, so for the agenda today, I'll speak very briefly as well. So my name is Katja Pech. I'm the coordinator of the Engine Room project. And the Engine Room project is so one of the projects under the NGI umbrella. And other partners on the project are DLab, the Digital Economy Lab at the University of Warsaw, and Euracat in Catalonia. And sort of, and they did a lot of the interesting data work as part of the project that we'll be talking about today. So you can go to the next slide. So some of you will probably be aware about of the Next Generation Internet Initiative, but for everyone who's not, the NGI is the European Commission's new flagship program that's really about building a more democratic and inclusive and resilient internet by the end of next decade. And what that means is that we both really have an opportunity here to think about what a radical new vision for the internet should look like. So we've so far been quite good always when it comes to the internet at diagnosing a lot of the issues, but where are the remedies? What do we want the internet to look like? And also to build a lot of concrete solutions and alternatives that we would need to get there. So as the Engine Room project, what we've helped the Commission with over the past year and a half or so, is really to sort of map what the current landscape around the internet looks like using data-driven methodology. So if you want to build this kind of new vision and want to know which technologies might be important a couple of years from now, you really need to understand where trends are heading. So for my next slide, to show that a little bit. So indeed, to do that, we need to know which technologies and issues might be important for the future. So if today we invest a lot of money in technology X, but it turns out that that technology is actually not all that interesting or is already getting a bit outdated, or there are other reasons why that's not so important anymore, that's a bit of a shame. So to prevent that and to really understand our early dynamics or early communities are growing around certain topics and issues, use this new data-driven methodology. So this is, of course, nothing new. It's policymakers and also in the private sector for a long time really thought about how making investment decisions or setting their strategies for the future about, I guess, what the future might hold. And in the past, how we used to do that was really using survey data, consultations, anecdotal evidence as well, talking to the people around us. What do you think might be the big next technology? What issue do you think will be very important? Those methods are good, but they're quite incomplete and also potentially quite biased because it's very much dependent on who you're talking to or who's filling in the survey, but steer the decisions that you make. Similarly, we've always relied in the past on census data, patents, data on where the government has been moving large chunks of funding towards, which is again also good information, important, but lags quite a while behind. So if you think about a patent, by the time, say, it's a new technology, and there's a patent made of it, you're many years down the line, right? Because you basically really want to know is not so much when a university has built a technology that's now ready to be developed or exploited, you want to know it from the very beginnings of their research. So this is always, you lead a little bit to these issues with time lags. Instead, so now with new big data methodologies, it's become a lot easier to I guess, sort of capture the early developments around new technology. So enough data like social media data, Wikipedia data that we've used in this project, trends in the news, what are technology publications talking about that might be interesting, what does funding look like, and particularly in the venture capital space, and sort of early experimental research funding, what are they looking at? So that's a lot better at capturing new trends. Because these methods are quite new, it's also really important to combine them sort of with qualitative insights, which is something we've also done. That's my next slide. So what this helps us do is to really make a lot more informed decisions about the future. So what are the early signals of change? Where do we see interesting communities emerge around the topic? Is that in Germany? Is it in China? Is it in Portugal? What are they working on? Particularly sort of more informal networks. So nowadays, a lot of interesting R&D doesn't necessarily happen in, I don't know, big companies alone. It also happens in maybe small grassroots hacker communities that are building the latest new tool. We can find that, we can find those using new methods. And what's important if we're there quite early, that we can still steer the development of these technologies, of these new tools in a bit more positive direction, right? So if particularly in this case, the European Commission can be there early, they can really have a head start at sort of building interesting new tools around these topics. So that's it from me. So what's going to happen in this webinar is that both Christophe and Michael from D-Lab and Laura, Christian, and David and Jurkat are going to talk a lot about the sort of enormous amount of methodologies, visualizations they've created over the past year. So I'll hand over to them now. Thank you.
So hello, everyone. My name is Michał. I'm a researcher at the Digital Economy Lab at the University of Warsaw.
Yeah, hi all, and my name is Christophe Györgyi. I'm also a researcher at D-Lab and a PhD candidate at the University of Warsaw. And we are very excited to share with you some of our results where we analyzed emerging trends based on news media.
So we'll start our presentation. Felix, could you please enable us to share our screen? Because we'll show our website. Okay, great. Okay, so I hope that you're able to see the website of the project. So as Katia has already mentioned, our project was highly data-driven. And our role at Digital Economy Lab was to provide text mining analysis of sources that are discussing emerging technological news and other technological trends and interrelated social issues from the wide range of sources. I will present the sources here. Okay, so here you can see the sources we have used in our text mining analysis. So mainly we used tech press articles from UK and US. We had 13 major sources, tech press sources. On the other hand, we used also academic repositories with working papers and academic journals. We have used as well social media posts from Reddit. We have scraped meetups from all around the world, meetups related to technological events. But today we will focus on results coming from text sources from technological news. We have around 140,000 articles scraped and analyzed through various NLP methods.
Exactly. So the basis of our analysis is that we have all these news articles dealing with technologies from the previous 3 and more than 3 years actually. So it is a vast number of news articles and also a rather long time period in order to see which are the technologies that are gaining traction and also which are the social issues that are related to the technologies that we are using currently, and also the technologies that are just gaining traction, the ones that reveal some sort of early signals that they will become important. And the basis of the analysis is that we have calculated term frequencies. So we know how many times various terms appeared in a given article. And we have calculated well, which are the terms that have encountered the greatest growth in frequencies. So by using such methods based on simple regression analysis, we were able to filter out from the text those keywords that have encountered the greatest growth, and we have manually selected from the top 1,000 keywords the most interesting, the most relevant. I have to say that among these top 1,000 keywords, most of them have been highly related to technologies. So it has been not a difficult analysis to find the most important ones. And we have selected both technologies and social issues. And we will now show you some of the interesting results. So from the birds' point of view, we have identified these technologies as the most important. The greatest group is related to artificial intelligence. And here you can see various implementations of AI, and also the most important algorithms and groups of algorithms that have been gaining the greatest traction.
Yeah, so the bigger the bubble, the more robust trend is we have identified. The same exercise was made for social issues, as Christoph mentioned. Here you can see, for example, a growing discussion around content crisis, let's call it that way. So here you can see that we captured all topics and smaller topics related to fake news, disinformation, election meddling, for example, or US topics like Infowars and Alex Jones that gained traction in recent years, but also some more regulatory issues like Section 230, famous section of related to a copyright reform in the United States. So you can explore it further yourself.
Yeah, so these are the major topics, and after that we wanted to dive deeper into this analysis. So the first thing that we did was this automated identification of emerging trends, and the next logical step for us was to dive deeper and find out, well, if we see that AI is gaining traction, or that privacy and also election meddling are something that we encounter in our daily lives, and we also discuss it more and more. Well, what are the words that are related to each other? This way we are able to identify the different sides of the debate, and also, for example, how technologies are related to social challenges.
Yeah. So in order to conduct this analysis, we have done so-called coherence analysis. So here you can see in this graph the words that are co-occurring with each other, so are mentioned together frequently in articles. So for example, in the case of surveillance capitalism, so issue related to commodification of personal data, hot topic recently, you can obviously see the relation with scandals around Cambridge Analytica and Facebook, but you can also spot the main authors writing about this issue, and the fact that the role of tech giants is mentioned here.
Let's say another interesting area which we found was the discussion around 5G. And in the case of 5G, it is interesting that on the one hand, you see all the discussion where this technology will be implemented. So a recent example are foldable phones, which have been recently released. On the other hand, we also see in the news, and we have also now revealed that indeed this discussion about threats related to 5G or cybersecurity threats, or the role of China, for example, as a massive player in telecommunication equipment, is actually strongly present in news articles. So this is why, on the one hand, you can see the application of 5G on this graph, but also related issues, including regulatory or political challenges.
Okay, so we know which topics are getting traction, we know which are mentioned together frequently, but how are people discussing those issues? So in order to find out, we have conducted basic sentiment analysis of the topics we have identified. And here we can see the results.
So it's maybe important to mention that that in our sentiment analysis, we are able to measure if a given technology is described in a positive or in a negative manner, negative sentiment. So the values are varying between +1 and -1, and those around 0 are neutral. +1 is most positive, -1 most negative. We have calculated this measure for different time periods, and this is what the graphs present, along with the number of paragraphs containing the analyzed word. And well, we have seen pretty interesting results. So as an example, if we examine GDPR, you can see how once we have been approaching the date of when GDPR came into force in May the previous year, you can see how discussion became stronger on this matter. How so the larger the bubble, the more paragraphs we have found, but also that the sentiment has become slightly negative over time, which may be related to the fact that several businesses have encountered potential problems for users. Sometimes this may have been something which is not completely positive. So we are able to see how these sentiments are changing over time. Yeah, Zuckerberg is a very interesting example. You can see how the different scandals related to Facebook had an impact on the discussion. So you can see two major falls. One around the presidential election in the United States, where the first fake news scandals have come into surface. Another major decline was naturally last year due to the Cambridge Analytica scandal.
Yeah.
The other interesting thing, maybe going back here a minute, is that we have always also been able to see the most positive and most negative words related to a given subject. So this way we see the two metals of the same coin. For example, the Chinese tech has been positively discussed in relation to machine learning, artificial intelligence. On the other hand, there have been all these scandals lately, such as the trade wars or the recent scandals related to Huawei. So these are these negative aspects of this area of discussion.
Okay, so we provide you a tool that will enable you to find what is the trend of several keywords we have identified. And you can do it across sources. You can do it in a 3 years and 2 months period, and find out which keywords are getting traction and which are not. So, for example, GDPR, as you can see, got hyped around its implementation in May 2018, and sadly, before this time, it wasn't so frequently mentioned in media, in tech media. But okay, so this growth was pretty impressive. But right now, as Christoph clicked AI, you can see the relevant importance of this issue in the media. So you can see that in comparison to artificial intelligence, this is a very small topic actually. So the regulatory issues are not so important in tech media as real technology. But for example, Cambridge Analytica. This is surprising for me, but it's more frequently mentioned than GDPR, for example.
During the Cambridge Analytica scandal, so you can see how several topics emerge, and then you have this spike, and then slowly the news became less relevant.
So we did this presentation around media, but you can also check how social scientists are discussing technologies, internet-related technologies, how STEAM scientists are discussing technologies, and so on and so on. On the website, you can find also a lot of geographical analyses. They are covered in the Research Hub section, but unfortunately, we won't have time today to discuss them. But if you have any questions regarding the analysis we have mentioned, or the other ones you can find on the website, please feel free to ask us any question.
Yes, and thank you very much. And we are also happy to take questions at the end, and also show you around some of the more geographical analysis that we have carried out. But these have been the major sections of our approach to identify trends and see the relationships between technology and social challenges. So thank you very much. And now we will, I think, start the sharing of the screen.
Hello. Thank you very much. So we are David and Laura from Eurecat. I'm a researcher in computational social science.
Well, I'm a data scientist.
Eurecat is the technology center of Catalonia, and we are the data analysis and data science and big data analytics group. So we will go back to the slides. So let me share the screen.
And in the meanwhile, I present myself. I'm Christian Consonni from the University of Trento. I have collaborated with David and Laura on this project. And now I'm in Lisbon at a conference, but I'm a PhD student in Trento, in Italy.
Yeah, we have collaborated with Christian, and he will help us to present the second part. What we are presenting are results based on Wikipedia and Reddit. These are two main references, main platforms in the web, and also, well, in some sense, they are relevant also because they are born from the internet culture. In some sense, they really represent a very wide, in a very wide way, public opinion. And also, they have the advantage that all the data are made available. So they have a different philosophy than other commercial companies, no? That keep that data for their business. So it's possible to study a wealth of data to see also what's behind the scenes. So in Wikipedia, is interesting for many reasons. We can see that it is really probably the largest repository of human knowledge, and it is relevant because it conditions and reflects public opinion at the same time. So it conditions public opinion because when we search for something, mostly we go to Wikipedia for many topics, and it's the first result for many web queries. And on the other hand, it is open, collaborative, and anybody can edit. And so when there is some point of view in society, it is very likely that you will find this reflected in the articles, or at least in the edit history of the article. So in the history of the previous change made. So as you can see here, there is on the left, we have article fake news as an example. On the left is what you usually see. It's the article about describing the topic, but on the right you see the edit history, and this is where all the change made to this article are tracked. And also the page views are available. And so we use different metrics to quantify different aspects of the popularity of topics and of the attention of internet users to the topic. So page views are a very good proxy for the popularity of a topic. So how many people check the article about fake news in Wikipedia during a certain month or in a certain language represents public opinion in some sense. And then we have several metrics based on edits. Here, I've just put two simple ones: the number of edits. So it quantifies the effort of a community to edit this topic, and so to build the articles and get to a shared definition, and then reverts that are when somebody undoes the edit of somebody else. And then this can be used to quantify controversy. We have different language editions of Wikipedia, so it's possible also to compare topics across languages. And we considered the 9 biggest editions of Wikipedia, which are 9 European languages. Okay, so now I let to Laura for explaining. We have done this analysis for a lot of keywords, of course, so we are here presenting just a few examples just to get a flavor of this one.
Yeah, so as David explained, the page views shows the interest or the attention of users over the topics. So what we have done, and this visualization is available on the web page that the lab has already explained, and we can select the topics that we want and see along the month the number of page views and yeah. So we can see, for example, in the case of filter bubble, how it's stable, the number of page views along the time, doubling its interest in the end of 2016. But we can also see, for example, for post-truth politics or fake news, how these articles were not existing. They were created at the end of 2016 and has had a really high interest at that time and grows really fast, having a peak of attention at, for example, in post-truth politics at the end of 2016, but it was decreasing really fast, while in the other case for fake news, it's still increasing. So we can also, well, we have this information also for the edits, for reverts, and some other metrics, but we can also do the comparison between the different language Wikipedias. For doing this, we have normalized the data so that we can compare the English Wikipedia with the others. And for doing this, we have normalized each of the topics with the total number of page views of their language. So we can see the relative, for each of the topics, the relative importance in their language. So for example, in the case of fake news, we can see that it's a new topic. It was not existing before. And we can see how, for example, in the Italian Wikipedia has been created later than the others, but the Spanish one even later. But it has grown really, really fast. And then we have the Reddit dataset. We have created this dataset taking all the data from Reddit from 2017 and half of 2018. We have all the posts from the Wikipedia, from Reddit, and then we have taken the posts which contains some one of the keywords that we want to analyze in their title. Then we have take all the comments related to these articles, and that was our dataset. So finally we have for each of the keywords all the comments that are speaking about these topics. We have applied the sentiment analysis to them, using the Luke dictionary, which make us able to have information about the sentiments or emotions, like the positive or negative emotions, but also the anger, sadness, or if they are speaking more, if they are speaking of the past, present, or the future, and some other metrics. So, for example, we have in this visualization the most negative topics that we have, and we can see see that the topics which are speaking, or the comments which are speaking about delete Facebook, are the ones who has more negative emotions or more anger, And for example, for anxiety, it's the brain computing
brain-computer
interface. Yeah, I can see. Or digital surveillance has more discrepancy than the others. We also can see these sentiments along the months, and so we have made this visualization, which is not so beautiful as the one in the web page, but it will look like them at some point, but it's not yet there. And we can have the different. We can choose the different sentiments and look them over time. So, for example, we have here we have selected some of the big companies, and we have the 2 Chinese companies, which we can see here the number of comments that are the Chinese companies are lower than the others, but this can be because the Reddit dataset is more used in the United States or in part of Europe, not in China. So this is the explanation. And we can also, for example, look at the future of these topics and see how Tencent is the one which is using more future tense in their vocabulary to comment these comments. So it can be because it's a growing company right now.
Thank you. So let's go back to Wikipedia. We have here the article Fake News. And now we have a look at another interesting aspect of Wikipedia, which is that it is a hyperlink network. So in which you see, for example, for defining fake news, some words are shown as links and some other not. Not all words are links, but only the words that represent a concept that is relevant with respect to fake news is a link. For example, you can see, let's see if I can do this. Yeah. So here you can see, for example, financial, political, these are not links because they are not concepts that are specially relevant to fake news, but sensationalist, this one is put as a link to sensationalism. So in a way, we have here a giant concept network because each article represents a concept and then it contains links to other articles that are the concepts that are relevant to this one. So we can see this as a giant mind map, but it is hard to make sense of this network. It's huge. Actually, we have retrieved the whole network. We have created a very huge data set for this. And so how to make sense of this data set? So the main question for us was, which are the most relevant concepts with respect to a given one? So given this article for news, which are the most relevant concepts? There are some algorithms existing, like the personalized page rank, but they are not able to really capture the most relevant and related concepts. So for example, when you run the personalized page rank algorithm, you find that United States is always the most relevant concept with respect to any of our keywords, or the New York Times, because this article attracts a lot of attention. So we developed another algorithm for this, and I now let Christian explain it.
Okay, so thank you, David. So as David was saying, there are some algorithms that can be used to find which are the most relevant nodes from a given reference node. The problem of these algorithms, as for example, personalized page rank, is that they consider just incoming links. So in an article like United States, it's going to have a nice score because it has a lot of incoming links. But in Wikipedia, not only the incoming links are important, like in the web or in the citation of scientific papers, but also the outgoing links are important because all of these links are put there by the community of editors. And they all link the relevant concepts one to each other. So we created this algorithm that is called the loop rank because it's considering the circular path. So the loops that go through the reference node that is provided by the user, that in our case is the page of interest. We see here a little example on a small toy network. Let's assume that we are interested in which are the most relevant nodes related to node 0. We find with our algorithm that there are 4 cyclic paths that go through 0. For example, 0, 1, 2, 0, or 0, 3, 4, 0. These are the most relevant nodes that are related to our reference node 0, and we are going to assign a score. So next slide, please. We see here that we assign a score based on how many loops the 2 nodes share with the reference node and how long the loop are. So we see, for example, that of course the reference node is going to have, by definition, as if for personalized page rank, the highest score, but the second highest is going to be node 9. And in fact, we can see that there is a double link, so a reciprocal link between 9 and 0. So these 2 concepts are really well tied together. And this is what our algorithm is capturing. So we have done this for several keywords, and we present here the results for fake news. This is the net of articles with rank score greater than 0. And we see that we can then cluster these concepts. And we have 4 clusters. We see Facebook and social media are 1 cluster. Then we have CNN, the New York Times, and for example, other television show. As was the case for the analysis of news presented by Michael and Christoph, we have a cluster dedicated to the United States presidential election and the Donald Trump campaign. And then we have a more generic cluster, which is about propaganda, disinformation, and several prominent figures in this area. We have done also a temporal analysis, since we have all the networks from 2001, and fake news exists from, let's say, the end of 2016. So we can do the analysis on 2017, and we see that the network was a little bit smaller. Some clusters are similar. For example, we have the social media, and then we have the news cluster and so on. But we can see, for example, that the Donald Trump cluster has become bigger, and also the Facebook cluster has become bigger. So we see that these 2 concepts are gaining importance in the context of fake news from Wikipedia because they are becoming more tightly linked to the page fake news. And as David was saying before, we have done this for 9 languages, so 9 European languages, where we are able to do this analysis across languages. And the nice thing about loop rank is, and using local versions of Wikipedia, is that it's able to capture some local concepts. For example, in French Wikipedia, you will find Emmanuel Macron among the top 10 results, which is something that you don't find in the other languages. And then you find similar clusters. For example, you have disinformation and propaganda that are going through all the languages. Another thing that is interesting is, for example, you find local publications. So Izvestia and The Insider are 2 publications that are in Russian. And so you find them up among the top 10 results from Russian Wikipedia, again, starting from fake news, the article fake news in Russian Wikipedia. So you see in the table. everything of this data set is already published on Zenodo, and we have made a dataset paper that has recently been accepted at ACWSM 2019 with all the code which is already on GitHub. And so we invite you to try to replicate our result or to use this dataset to learn more about other pages or the topic of your interest. And so I go back to David.
Yeah, thanks a lot, Christian. Yes, so here are the links to GitHub and Zenodo. There are not only the dataset for the Wikilink graph, but also dataset for Reddit, for news, and also for what Michal and Christoph have shown. So now I think it's time for questions. I will stop sharing my screen. Manage. Yeah.
Hi, hello. So yeah, if you have any questions, please unmute yourself and ask them. Don't forget that you're currently muted and we can't hear you, or just put them in the chat if you don't want to speak or don't want to unmute yourself. Go ahead. Otherwise, if we don't have any or many questions, I think there was some material that we left out of the presentation. So you can come in with that. Okay, looks like there aren't really many questions so far. Oh, hang on. Yeah, there is one. Okay, so just in case not everybody can see that, there's a question about just kind of to repeat the tools you guys used for this analysis. Maybe you can run through that quickly.
Sure. Yeah, so for the web scraping of media news, we have used Selenium WebDriver, and in our case, the entire pipeline has been prepared in Python, and we have also uploaded the repository with the codes on GitLab and also on GitHub.
And the datasets on Zenodo.
And datasets are also available, so everything has been made in Python. And when it comes to the turn frequency analysis, we have used NLTK package and also custom functions. And so there was NLTK for data cleaning. Maybe you want to also tell a few words about the data visualizations.
Yeah, so most of the data visualizations are done in JavaScript, but some easier ones are done in Seaborn, so Python package. I see there is another question regarding the coding, to know coding to use. Yeah, so the very important part of this project was to do it in a reusable way, so that non-very technical users could replicate our results. However, the basic programming skills are necessary just to run our codes. We have put a lot of effort to comment the codes for users with not a huge background in programming. But if you know the basic of Python 3, you should be able to start. You're able to start and do this analysis for other periods of time.
So, for example, you can use, you can scrape the websites yourself. You can also just download the results of the different frequency calculations and filter the results yourself. Because what we present is there is some sort of expert verification at the end, which is not substantial, but it is also useful for users to explore the results themselves. Yeah, and sure, we can send the link to the GitHub, and we will do that.
Yeah, so if you know just the basics of pandas and NumPy, so the most frequently used packages in text analysis, in data frame analysis, I guess you'll be able to start. We have made some custom functions. They're all commented. But there are some parts of the analysis which are really easy to reproduce. So the one we didn't show you about, so topic modeling, for example, we used the PLDABs. You can see it in another tab on the website. So
yeah, so the altogether, to put it short, there's a README file which includes the what should be the good order of using the codes, and so it is possible to replicate everything. Yes, that's another question
for Eurecat. Media data sets. No, we used only English websites and English sources. So in case of academic sources, this was not very controversial decision, as most of good papers are written in English. In case of media data sets, it was a hard decision, but we wanted to use a simple, coherent framework. And as you probably know, text mining analysis, NLP analysis of different languages is a very challenging subject.
We had the time constraints, so we are now planning to also include different languages in the analysis. But as we needed to have reproducible and easy to interpret results early stage of the project, we focused on English. So like Ars Technica and also Guardian. So also both technology focused news and also policy oriented news which are related to technologies. I think that.
Yes, from Eurecat's side, we also, in the case of Reddit, we also used only English. It's the largest part of comments are in English. There are things in other languages, but as the kind of analysis we performed on Reddit data was sentiment analysis and even emotion analysis. So it's also very, let's say, very difficult to replicate. There are tools also for different languages, but in this case, we just took, consider that with all the keywords we looked at, I think we had more or less 10% of the whole Reddit during 1 year and a half, just taking the English language. And then there are conversation about a lot of other topics. These were just all the discussions in Reddit to some articles, some posts having in their title some of our keywords. Yes, in the case in Wikipedia, it was different. We performed a language agnostic analysis. So all the analysis we made in Wikipedia doesn't depend on language. And therefore, it was much easier to consider different languages. So we managed to do it both for the trends of the keywords and for the networks.
And if I can say, the advantage is that the structure of Wikipedia is similar across the languages. So basically, it's once you can process one language, it's not so difficult to extend the processing to other languages, which is very different if you are using data sources like Reddit or the media sources.
So we see a question from Rafael regarding the visualization. We didn't have time to mention. I will share the screen a moment. Where is it? Here. Yes. Okay. Desktop. Okay, here we are. So we briefly mentioned that we have done some geographical analysis. Okay. And here you can see the result. So in this graph, we have scrambled a lot of different dimensions. And in the left axis, y-axis, you can see the division between United States and European Union sources. European Union is can be a bit misguiding because we have used only UK sources, but also checked if in any source there were mentions about European capitals or other cities or European subjects.
So
right?
the idea is to evaluate if articles that are discussing European matters or which are based in Europe, if the discussion in these sources is actually covering different areas, or are there any stronger emphasis on various topics when we compare them to American sources. And so this is a very compact picture, as Michał has already mentioned, because you have this upper and lower section of the analysis, which contains whether a given word is more associated with articles from the European perspective or from the American one. And on the other hand, you have this dimension of technology and social, whether a given word is more relevant for articles discussing social matters or technological matters. And the methodology became a bit complex as we iterated this analysis. But the most important sections of the graph are its corners.
Yeah, so there are some easy takeaways from this graph. So as in the case of the previous visualizations, the bigger the bubble, the more articles contain a given word. And as Christoph mentioned, there are some interesting corners. So the European and social corner that covers, for example, GDPR, but also problems that seemingly would be US problems like far right recently, right? But this is more discussed in the European context. Scandals regarding GDPR, Cambridge Analytica, and Facebook's again here in Europe discussed more often. On the other, so the opposite,
which is much less. Actually, the opposite corner is much less crowded. So we had this initial results which show that actually European sources or sources in the European context are more discussing social issues, that there is some sort of higher importance of social challenges in our discussion in Europe, which we found very exciting, and also I think it also reflects what we see in terms of regulations, for example, in Europe.
So what I found interesting also is that discussion about technologies is very different in US and Europe. So in America, they're discussing more frequently issues relating to personal IoT stuff like HomePods and Alexa, such issues you can find in the
technologies.
Exactly. And in the case of Europe, more technologies with more potential to drive future technological landscapes. So 5G, for example, or multi-cloud computing.
Also, the serverless technologies related to cloud computing, like Kubernetes.
So gadget versus meaningful technological change.
Yes. Also, like qubits are more related to European sources. So, like the short story on this graph is that there is a potentially higher focus of European sources on social issues, and American ones are more focused on consumer technology. And the technologies that appear in European context are the ones that we have picked up as emerging, and which are in the current state more of a promise than as an already widely used technology, like quantum computing naturally, and also cloud computing technologies.
Okay. Hope it helps with your question.
Yeah, so if there are any more questions that we can answer, we are still very happy to.
There is one follow-up question about, did you see it from Alex, about the demographics behind the US-EU?
So in our case, we don't capture anything about demographics. So we could only do some research on the authors, so networks between the authors of the articles. In the case of Reddit, so the only source where we could do it possibly, the problem is that this is a very anonymous group of people, and they don't share a lot of information about themselves. So we don't have a lot of data on this level of granularity. Maybe it would be the case of Wikipedia. I don't know.
No, actually, Wikipedia has the same issue. Let's say it's very anonymous people, and so this, I think this is a bit out of our possibility. Maybe I would take advantage to show one last thing, if there are not other questions. So do you see this? Can you see it?
Yeah, we can see it.
Okay, so this is the interactive version of the network for fake news. So just to give you an idea, it's very dense. You can zoom in and then you see more concretely. You can have, for example, you want to know why Pope Francis is there, then you can pick it. And you will see only the connections involving Pope Francis. So you see that Pope Francis was involved in all the issue of the Donald Trump presidential campaign. There were some fake news stating that he had officially supported Donald Trump. So you can see, inspect now with which concepts within this fake news environment, with which concepts Pope Francis is connected, to just an example. And then you can, so this is the whole network, and that was showing only the articles connected to it. And then you can see clusters. So for example, if you want to look at, inspect this cluster about Donald Trump, then you can zoom in a bit. Okay, and now you see only these concepts. I don't know, we made this for several keywords, and also some more general network, including using as seed different keywords from social issues related to NGI. Okay.
And just to say one last thing, the extraction, the code for extracting data from Wikipedia is written in Python 3 as well. And as Laura mentioned before, we use the Python notebooks. So let's say that in general, Python is your language of choice if you want to replicate what we have done. And the part about loop rank is not public yet because we are writing an article about it, but it's in C++, and it's it's one of the few non-Python parts of the whole thing.
All right, cool. I think that looks like we've reached both the end of our time and the end of the questions. Of course, if you do have any more questions, feel free to just get in touch with me under my email, and then I can forward that to anybody else who might be interested in answer or able to answer it. As I mentioned, we're going to upload the recording of this webinar online on the NGI.eu website, and we're also going to keep updating the resources on the links that I shared earlier, as well as kind of keep uploading our work. And also Katja as Katja mentioned on the chat, we've got some more work coming out, how people can use data this kind of insights without being super familiar with data science. Yeah, that's kind of it from us. If you have any questions, please get in touch and keep following the NGI project, which is going to be ongoing. Thank you.
Yeah, thank you very much, guys. It has been a great pleasure for us to show the visualizations, and have a nice day. Thank you for the interesting questions.
Yeah, keep in touch.
Bye. Thank you.
Bye-bye.
Bye.
Thank you very much. Bye.
Bye.